Okay, so the good part about review is if you know what you're doing, it's like a break. If you don't know what you're doing, crap, I still don't know this stuff, and now I got to do more of it. Okay, so everything we're going to do, except for that 1%, which is actually an easier concept than all the rest. But if you teach it first, it makes the rest all very complicated. Okay? Now, let's first talk about when you have asymptotes. Now, I don't even notice that. Look at that. They're mixed up. Those are virtual asymptotes. Oh, no. You don't have any chance now. I spelled virtual wrong. Now, vertical asymptotes will occur when there is no factors in common. Okay? If there's factors in common, which we just dealt with 3 minutes ago, you're going to get points of discontinuity. Okay? Now, these little nuggets of information, they're things you will forget in a month. Okay? So get those on your study sheet. This is when you're going to have this nice concrete rules. So when you read them, you're not wondering, what do I mean by that? Okay? Now, you got to be careful that if it does have common factors, and it does have things left over as well, it can have both at the same time. It can have vertical asymptotes and a point of discontinuity. Okay? Now, we'll do some examples to sum all this up. The horizontal asymptotes, again, they're rules, but they should kind of make sense. Now, if the degree of the numerator is less than the denominator, so an example would be like, 2x over, over 3x squared, What I do is I take the two biggest, so the biggest on the top and the biggest on the bottom, and I just deal with them. And if I cross the x squared would go. So this would be 2 over 3x. And then I substitute infinity in there, and what would it equal? And 2 divided by infinity equals 0. Okay? Now, why am I showing you this? You're like, I'll just memorize okay? Well, it's nice to have confirmation of your memorized rule, because when you have too much memorized and it all gets mixed up on that one day, it's just panic time. Okay? And it's like, okay, whoa. How can I, let me try something on my calculator so I can verify this. Now, when you have the same degree on the top as on the bottom, so an example there would be like 2x squared over 3x squared. And those cancel, so you actually get 2 over 3, I should put 0 there for that one. You will get 2 over 3 as the asymptote. Okay? Now, if you had the degree larger, so say you had 2x squared over 3x, okay, the x's cancel, so I have 2x over 3. Now, if you put infinity in there, well, that's just 2 times infinity divided by 3. Okay, just believe me, infinity divided by 3, still infinity. Okay? That one's getting away from you. It changes every time I put something in there. So this one, we're not going to talk about how to get that asymptote, but we have to understand that it will not be horizontal. It will be oblique or slanted. Those mean the same thing, by the way, oblique and slanted. Okay? So there's our rules for horizontal. Now, point of discontinuity is about 3 minutes old. That is when you do have a common factor, right? And that's just your open circle point of discontinuity. And here's the rules: factor, simplify, and then substitute. Now, just be careful. Sometimes you can have both, okay? So if I had 2x plus 3 over 2x plus 3 times x plus 2, I would have a point of discontinuity at where the point of discontinuity be at? So I'm glad we had this little talk. Negative 3 over 2, and we'll have a vertical asymptote at negative 2, right? So sometimes you can't have both. You can have your cake and eat it too. Okay, now the next one, see that's like 1, 2, 3. The next one is actually called, here, some of you still writing. The next one is called, it's a rational function that has no discontinuities. Okay? So this one actually, if you teach this one first, it actually makes the other ones confusing. Okay? So we dealt with all the things that mess with you, that you're getting horizontal, you're getting vertical asymptotes, you're getting points of discontinuity. When can you actually have an x on the bottom and it's not bad ever? Okay, that's not possible. It is if you had a situation like this. It is impossible to make 0 on the bottom. Now, how some of you like to put yours into your calculator, you do get asymptotes. Because, well, let's just play a game here. You're making a test, and this is the multiple choice question. It said, consider this function. What would be the discontinuities? Obviously, I've already given you the answer. B is there are no discontinuities. You're making this question on a test, and you got to come up with 3 distractors. What would be good? 3 good distractors. Because distractors are often harder to make, actually, than the right answer. What would be 3 distractors? -1, absolutely.
Grade 11s who are going to the Citadel, you may leave class now and make your way to the buses. They are leaving fairly quickly. Please pay attention to where your name falls into the range that is supposed to go on that bus. Check the sign.
Okay, so -1 would be, let's just talk about distractors, okay? Now, distractors are wrong answers on an exam for students who do not know what they're doing. So a good distractor would be -1. Why? Because this is what students put in their calculator. -1 squared plus 1. I want you to put that in. -1 squared plus 1, just like you see it. You will get the answer 0. Okay? Because I still have students doing it that they are not substituting with brackets. Now, if you don't substitute with brackets, I would just not even answer the question, because you're not going to get any marks for it anyway, right? So move on. At least have time for other ones. Just write a note to yourself. I did not substitute in brackets, so I will get this one wrong anyway. Okay? So -1 would be a great distractor. What would be another one? 0, yeah. 0 would be another good distractor. And actually, the third one would be kind of hard to come up with. I might just put 1, maybe. I don't know. Okay? But if you even try this mathematically, well, what does a squared plus 1 equal 0? Okay, well, let's do the math. -1, x squared equals -1. I take the square root, x equals plus or minus the square root of -1. Oh, I can't do the square root of negative 1. Okay, yeah, you're right. That's why. There is no possible solution that would ever get you the answer. The bottom is equal 0. And that's the only time it's bad. Now, if I was to even do this one better, I would put, it would be x over x squared plus 1. And I would have students that would say 0 for sure if they didn't know what they're doing. And then we discussed it after they bring up the exam because they're like, how come 0 doesn't work? And I'm like, you can always have 0 in the numerator. And they're like, oh, crap, I forgot about that. Okay? Because people are getting numerators and denominators mixed up. You can always have 0 up top. Doesn't matter. You can never have it equaling 0 on the bottom. That's bad. Okay? Now, here's a really simple example. If I just gave you this, what would the answer to this be? Okay. Is there an asymptote? Would there be an asymptote at 0? Would the answer just be 1? Yeah. Well, the answer to this would be, is the answer to this 1? Good question, eh? Sometimes the simple ones are the ones the hard, like x over x. Yeah? Yeah, because x cannot equal 0, right? So this would be a point of discontinuity on this one. What would be your horizontal asymptote? 1. Okay, because remember there's 1s here. They're both the same. I cross them out. Horizontal asymptote would be 1. Okay? Now, we're actually going to just move in that direction now, and I just want everybody to turn to this page here. Now, what I like about this example, even though this is a bit more simple than would be on a diploma, is these are really good numerical response questions. And they just may have these numbered like 1 to 9. There could be 9 of them. Okay? And they'll say in blank number 1, which equation has no discontinuities? Okay? In blank 2, which one has a horizontal or a vertical asymptote? Okay? Next one may be which one has a point of discontinuity, and the last one, which one has a horizontal asymptote, or maybe it just says which one has no horizontal asymptote. Again, a really good question if you know your rules, and wow, is it hard if you don't. Okay? Because just looking at these equations, it may be overwhelming, but if you know what to look for, these really can help you kind of learn all of them together. Okay? So, which ones would have no discontinuities? Now, come on, in my head, what rule am I looking for? What am I looking for having no discontinuities? What process has to go on upstairs here for me to go, that's what I'm looking for? This is how I'm going to test it. This is what. Anyone got any idea? Yeah? Good. Can we write that down here? When the bottom can't equal 0. Okay? Or doesn't equal 0. Might even be a better, you know. There's no way I can make the bottom ever equal 0. Now, looking above, can I make A equal 0? Can I make that bottom equal 0? Yeah, put a negative 4 in there equals 0, bad. Okay? I'm looking for which has no non-permissibles. Okay? Again, not the most grammatically correct sentence. No non-permissibles, that's a double negative, right? So which one has only permissibles in it? And that doesn't make sense. So which one has no non-permissibles? B? I would say B. You cannot put anything in there to actually make the bottom equal 0. How about C? I could put 2 in there. 2 squared minus 4, that equals 0. G? Right. If you take out the negative, you still have B, right? So I'm good with that. There's nothing I can put in there to make that equal 0. Okay, there's one more. Which one is it? I can put negative 2 in there. That's I. Which one do you want? Okay. Yeah, if I put, like, if I factor this out, there's 2 bad ones, right? 0 and 2. What's the other one? If I put in okay, I'm just messing with you. There's another one. It's hard when you have this position of power. It's hard not to abuse it once in a while. Okay, you would too. Okay, now no vertical asymptotes. Now, what am I looking for when I have no vertical asymptotes? Yeah, everything in the bottom cancels. Right? Are these the kind of rules that you can put down on a study sheet? Now you're like, okay, yeah, that's when I'm going to have no vertical asymptotes. Now, obviously, I'm going to have no vertical asymptotes if there's no x on the bottom anyway. Okay? But in rational functions, since these are all rational above, which one everything cancels? Okay? Okay, I. So what's, how did you get it to cancel? I can't cancel anything. This is x plus 2, x minus 2. So those both cancel. So there is nothing left on the bottom. Okay, so I got I. What else? J, how'd you factor it? Okay. Okay. Does A cancel? Yeah, that would actually make that a negative x plus 4 if I took out a negative. Okay, how is B going to work? I could factor the top would be x plus 2, right? X minus 2. I'm still not canceling with x squared plus 4 though. there's two more. Maybe. Okay. Now, this is a good question. And Brooke had it, but you talked her out of it. Okay. Why is B? They don't cancel. But B does not have a vertical asymptote, does it? Because nothing's bad in it in the first place. Remember, look at no discontinuities. Will this have vertical asymptotes? So B and G should be there too. Like nothing's even bad in them, so why do they have vertical asymptotes? So everything in the bottom cancels, or I would say A, when the bottom can't equal 0, right? So again, that's a tough question, because if you're looking for just the bottom cancels, you would not pick B and G. But you guys already told me 2 minutes ago you agreed that that didn't have horizontal asymptotes or vertical asymptotes, right? Okay. Now, no horizontal asymptote. Okay, again, maybe now you're starting to see why this is a really good question, because you have to know your stuff. What am I looking for no horizontal asymptotes? So degree on the top is bigger than, is that right? Degree on the bottom. Okay, so what are we picking? E, I, and J. Okay, let's just do E's a good one. Now remember, take your two top. Yep, that one's bigger. And I, that one's bigger. And J, that one's bigger. That's good. Okay, which one? The x-axis is the horizontal asymptote, aka y equals 0. So when, which ones, what's the rule? So bottom, or I could just write it, degree of top is less than degree on bottom. Okay, so which one are those? C, D, G. Okay? A horizontal asymptote with y equaling to 1. What am I looking for? So same, coefficients, and same degree. Now again, I'm talking about on the largest one, right? I don't really care about the rest of them to figure this out. So they got to be the same. Now all of these are the same because all the big ones have, now sometimes they could have negative, one positive, one negative, right? So you could have a negative one. Which ones? A, B, F, and H. Okay, which ones would have points of discontinuity? What are you thinking in your head when you're thinking points of discontinuity? So we do have canceling. So canceling occurs, right? Okay, so looking above, which ones would you say canceling does occur? D, because this turns out to be x plus 2, x minus 2. So D, we have canceling. Okay, I already showed you there's canceling, so I know I'm going D and I. Okay, so j is the one that a lot of people would not see. So you can factor this to be x squared. That's x minus 4. And then the bottom you would have x times x minus 2. Right? Now again, some of you are going, oh, that doesn't cancel. Yes, it does. You have an x squared and an x here. This would cancel. So you would have a point of discontinuity at 0. So D, I, and J. Okay? Now, if you think about the amount of time we spent on that, about 20 minutes, that could be just one numerical response on your diploma. Okay? The amount of knowledge you need to do that is, 5-6 hours of work to be able to do this one after. Okay? Now, one more question. So algebraically determine the equations of the asymptotes and any points of discontinuity. So let's get, and then it wants domain and range. Domain and range. Always wants domain and range, right? So, any vertical asymptotes. How do you find those? It's when it makes the bottom equal 0 and it hasn't canceled with something up top. So we should probably factor the bottom first. And that would be x minus 5, x plus 3. Okay? So what would be the vertical asymptotes? Negative 3, right? Because that cancels. Okay, let's do point of discontinuity. Now, if it wants the point, we have to give it the x and the y. So what is the point of discontinuity? See, we haven't had one of these yet, because we did asymptotes the first day, 2 days ago, more than 2 days ago. So we know the point of discontinuity be when x equals 5, right? So it's going to be 5 comma something. Now, you want to take your new equation after you've canceled, and you want to put a number that is not allowed to equal into it. So that would give me 2 times 5 is 10 minus 1 is 9 over 5 plus 3 is 8. 9/8. So 5 comma 9/8. Okay, so see how I got my vertical? I got my point of discontinuity. Next, it is the horizontal. Okay, now it looked like they were being all nice to us because they factored the top, right? But really, when I find horizontal asymptotes, do I want to use the factored form? I actually want the unfactored form. But you don't have to do the entire FOIL. Just do 2x times x to get the first term, right? So the horizontal asymptote at the top would be 2x squared, blah, 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 whatever comes after, who cares? And the bottom would be x squared, blah, blah, blah. Okay? So now, if you know your rules, bang, bang. So the horizontal asymptote was at 2. Okay? Now, if you're a visual person and you're thinking domain and range, could you even graph this one? Okay. Now, what you want to do first is you want to put your vertical asymptote, and that is at -3. Okay. Then you want to do your horizontal asymptote, which is at 2. Okay. And I also want to do my point of discontinuity. Now, what's 9/8? It's like 1.1. So the actual point is 5, 1.1. So 5 and 1.1 might be like right there. Okay. So that is 5, 9/8. And the way this graph would look would be like this. And then it kind of goes like this. And it comes to 2. Now, if you graph this in your calculator, you'll see that it looks like that. Now, what would be the domain of this? X cannot equal -3 or 5, right? So when you do domain, remember, it is your point of discontinuity and your vertical asymptote. That should go in there. And what about the range? Y cannot equal 9/8. Now, can it equal 2? It could. But in this case, it doesn't. And I can see that right from the beginning. It'll happen at the beginning if it's going to cross. And then it'll level out to 2. But you can see this one didn't happen at the beginning. Okay? But I would definitely check it with your calculator to see if it does or not. And you can just keep going along, and see it'll just get closer to 2. But it won't ever equal 2 as well. It is. It won't. It won't happen. Okay? Okay? So today, all you're going to be doing is everything you've done up to now, all in one. Homework, which is where things start to get a little harder. Right? If you've done a good study sheet, stick with it. And that's why that study sheet becomes quite valuable for you during the test, because if you've been using it, you will have it memorized. Not because you've sat down and memorized it, but just through usage, you do get a photographic memory. Okay, it might be pure coincidence, but last test had the highest percentage of you guys doing study sheets. And like I said, it is the first time.